one. We're running a little bit behind. Next up is Gabby Studebaker. Gabby is a graduate student with Oregon State University, and we'll be talking about potato nematodes. Old problem, new information.
Yes. Okay. Thank you for that. So yeah, I am a master's student at Oregon State University. And yeah, I study potato nematodes. So, okay, so quick outline of what I'm going to be talking to you today about. We're going to go a little bit over nematode biology, and then I'm going to introduce the PAPAS project in case you guys haven't heard about it yet. And then I'm going to talk about my own research and the damage potential of root knot nematodes on potato. And then I'll finish up with some management notes specifically about sampling. Okay, so nematode biology. There's lots of major groups of nematodes that we're concerned about, and depending on what crops you grow and your field history. But there's three major ones that we're concerned about with potato that I'm going to talk about, and that is the root knot nematode, stubby root nematode, and the root lesion nematode. So before I get into specifics about each one, I want to give some context for each of these groups based on what you might find in a typical soil sample. So in the chart, I've listed the percent occurrence, the average count, and the maximum count per cup of soil that was found in a Pacific Northwest fall soil sample from the years 2012 to 2016. So these numbers are telling us that when nematodes are present in a soil sample, we typically find them this often and at these population densities. So we can see that these numbers can range quite a bit, but this is generally what you would expect to see. So generally you see root lesion like a lot, almost 70%. And you don't find root knot or stubby root nematode as often, but the population density of root knot is pretty similar to root lesion when you find it. And then the other thing is stubby root, when you find it, has a really, really low population density. And when I go, I'll talk about that a bit later, but when I go through each one of these groups individually, you'll see an adapted chart just to remind you of like what these numbers we would expect to see are. Okay, so first up, root knot. I'm going to go a little more in depth about this because this is the specific nematode I study, but these are Meloidogyne species. So this includes Meloidogyne chitwoodi, which is the Columbia root knot nematode, and Meloidogyne hapla, the northern root knot nematode. So these nematodes are sedentary endoparasites, meaning that as they progress through their life cycle, they will enter the tuber or root of the plant, and they're going to stay there for the rest of their life. When this happens, it causes blemishes beneath the surface of the skin, and with the Columbia root knot nematode, you'll also see galling on the surface of your potato. These have a pretty wide host range, which can include potatoes, wheat, corn, oats, tomato, and alfalfa, and we find them in all the potato growing areas of Washington, Oregon, Idaho, Colorado, and California. The differences between these two species that I want to point out is that the Columbia root knot nematode does cause galling, and that it develops at lower temperatures than the northern root knot nematode, which is why the population densities may differ in a soil sample. And then the other thing I want to note is that the Columbia root knot nematode is a global quarantine pest, and there's a 0% tolerance for infection if you're trying to export potatoes outside of the country. Okay, so next up is the stubby root nematode. So this is the Paratrichodora species that you might be seeing. And these are migratory ectoparasites, meaning that as they go throughout their life, they're going to move around in the soil and feed on the outside of roots or tubers. So they're never actually going into the potato plants. And the important thing about the stubby root is that they have the ability to transmit the tobacco rattle virus, which is the causal agent of corky ring spot in potato. Again, these population densities are really, really low compared to the other two nematodes we're talking about. And this is important to consider because if you get a nematode diagnostic report that doesn't report finding stubby root nematode, that doesn't mean that it's not present, and it doesn't mean that there's no risk in your field. I'll talk a little bit later about why that may be the case. Okay, finally, the root lesion nematode. These are the Protolinkus species. These are migratory endoparasites. So as they progress through their life, they'll move throughout the root tissues and feed on the plants. So we see these nematodes a lot and about the same population densities of this Columbia root knot nematode. And these nematodes can cause reduced yield and necrotic lesions on the tubers, which make them unmarketable. And they also create entry points for the fungus Verticillium dahliae, which causes early dying of potato. So when they're present together, this nematode will worsen the severity of verticillium wilt that you may be seeing. So all these nematodes cause their own problems in potato, but overall, the problem is that they're production limiting. Yield loss can range from 10 to 80% depending on your nematode, your field, and tuber damage will lead to rejection. They're also really hard to deal with because species present will depend where you are and your field history. So to address some of these problems, the PAPAS project was formed. So what is PAPAS? PAPAS is Potatoes and Pests Actionable Science Against Nematodes. This is a team of researchers, educators, and stakeholders who are working together to develop solutions to effectively control potato nematodes. PAPAS was funded by the National Institute of Food and Agriculture Specialty Crop Research Initiative Program, and it was $6.8 million over 4 years. So the mission of PAPAS is to develop a systems approach control to plant parasitic nematodes. And like I said, it's made up of primarily researchers. And so here on the slide, I have all of the co-directors of the project. I think a really cool thing is that it's across the Pacific Northwest. So we have people from Washington, Oregon, and Idaho. And each one of these researchers works on a different part of the PAPAS objectives. These objectives are to improve diagnostics and implement predictive models, mine plant defenses for novel resistance, plan for the future through smart nematicide chemistries, and engage with stakeholders. And like I said, the goal and the mission of this project is create a systems approach to nematode control. And so the overall idea is that at the end of this, we'll create a decision support system, which takes a whole bunch of data about all of the different factors that a grower might be thinking about and help them input information about their specific situation, and then it'll output what might make most sense for you in terms of management. So a grower could be thinking about environments like soil type or climate, chemical controls, what rotations, and then economics of all this. So this is a lot of data. I, as a graduate student, do not have time for that. So in collaboration with PAPAS, I focus on nematode thresholds and variety parts of this system. So this leads into my own research. So this is the damage potential that root knot nematode has on potato yield and quality. So to ask these questions, I have a field trial at the OSU Hermiston Agriculture Research and Extension Center, where I've planted 3 varieties of potato and inoculated with the Columbia and the northern root knot nematode. The 3 varieties we planted include Ranger Russet, Russet Burbank, and Clearwater Russet. And once the potatoes were in the ground, we inoculated the field with 3 densities of nematodes. This included a non-inoculated control, so 0 eggs, a low, which was 50 eggs per about a cup of soil, and then 200 eggs per cup of soil. And again, these densities were chosen based on those typical soil sample densities you find. And I have a QR code on the screen that takes you to a YouTube video that walks through how we went about putting nematodes in a field. Okay. So from the field at harvest, we sort the potatoes and assess for 3 groups of characteristics. This includes yield, which we're looking at weight and our total numbers of tubers, internal quality, internal brown spot, black spot blues, and vascular discoloration, which you can see in that image. And then external quality, which can include shape uniformity, growth cracks, and knobs, and galls. So all 3 of these groups are things that would be assessed in potato processing and could lead to tuber rejection if they were not considered good enough. I just wrapped up my second of 3 field seasons, but I'm only going to share with you the results of the first season. So first up is yield results. This is specifically looking at the Clearwater Russet variety. In the 2 graphs, I show the average total weight and hundredweight of the tubers from harvest. So on the y-axis is the average total weight and hundredweight. 1 hundredweight is equal to 100 pounds. So when you see on the y-axis of 40, that's 4,000 pounds of potato. We saw that the Columbia root knot nematode had significant negative impacts on the total yield at the high population density, which is slightly above that average you would see in a soil sample. And it reduced yield by about 1,500 pounds, which is quite a bit. And then looking at the northern root knot nematode, it didn't have any impacts on the Clearwater Russet variety. Next, we looked at one of our external qualities, galling. So we measured galling through scoring, and this scale evaluates the amount of tubers in a group that showed the galling symptoms. So a score of 1 indicated that none of the tubers in that group had galling. A score of 3 indicates that about half the tubers in a group experienced galling. And then a score of 5 indicates that all of the tubers in a group showed galling symptoms, like in this last image here. So looking at the results, in the graph, I have the potato varieties grouped by their inoculation density, and on the y-axis is that gall score. So again, a 1 means that we saw no galling, and a 5 means that all the tubers are galled. You'll notice that the northern root knot nematode graph is missing because northern root knot nematode doesn't cause galling. So I only have the results for the Columbia, but we can see that as the initial inoculum density increased, galling got worse. And here I have a visual representation to show you what that kind of looked like. So these photos show 3 ranger russet tubers from that high inoculation density, so 200 eggs per cup of soil. And we can see that there's lots of galling on the Columbia root knot tubers, but nothing on the northern ones. So we can say that the Columbia root knot nematode will cause severe galling of tubers when present, and northern root knot nematode won't. So far, that was only part of the story of what I was been looking at. After harvest and assessment of yield and internal and external quality, a subset of 10 potatoes from each group is stored for about 3 months to mimic storage and processing of your standard potato. At which point we grade them for infection index, proportion of infected tubers, and percent culls. This grading process is done by lightly peeling the potato and then counting the number of infections that you see on these small brown spots that will be pointed out with the arrows on the screen. I have a QR code that takes you to the full-length YouTube video that we made if you're more interested in this process. Okay, so when we peel the potatoes and we see these small brown spots, we want to think like, what actually are we looking at? And these are the nematodes. So looking closer at each one of these, each one of those brown spots is a female root knot nematode that has established her feeding site and is completing her whole life cycle, and at this point is now filled with eggs. So apart from just seeing that we do in fact have nematodes in our potato, we can count these spots, and when we count those, we can create our infection index. In this index, we're counting these nematodes. So a 0 means we saw no nematodes, and a 7 means we saw more than 100. Here I have the graphs showing the average infection index that I saw. Again, the varieties are grouped by their inoculation density, and we can see that both nematodes had a significant impact on their infection index. Your samples is also important. Different nematodes will develop at different times, and in these 2 graphs, you can see there's different population peaks. So on the stubby root one, you can see that the populations peak in the summer around June and July, and the Columbia root knot nematode populations peak in the fall around September, November. So it might not be feasible to sample at both times, but if that's the case, make note of what you might be missing from your soil sample. I think this also ties in to your sampling number. If you take lots of samples, but you take them at the wrong time, you may be missing your nematode populations or severely underestimating them. And I think this kind of goes back to that stubby root problem. The numbers I just showed you were from the fall, but we can see that is just not the time to be sampling for stubby root. So we expect to see lower numbers in the fall for stubby, but if you were to walk out in June or July, you would expect those numbers to be quite high. Okay, sampling depth. Your population numbers may just vary at different depths. This table shows the different populations of the Columbia root knot nematode and its eggs at different depths. For context, 30 centimeters is about a foot. So we can see that the majority of nematodes and their eggs are within this 0 to 30 centimeter range. And you want to make sure that's what you're collecting in your soil sample. So you should be going at least 1 foot down and near the roots of your plants because this is where they're likely to be. Okay. Soil property should also be considered. You know your own fields best. If your soil type changes throughout a field, make sure you take samples in those different soil types because we may observe different populations in different areas. And field history in terms of cropping and past nematode knowledge is also important to consider. The Columbia root knot nematode has 2 races with a different host range. So race 1 cannot infect alfalfa, but race 2 can infect alfalfa. So these differences and knowing what actually is in your field will impact your rotation in terms of crops, length, and then also what fumigants or nematicides you may be using. Okay, all of that was a lot of information, but I want to direct you to the PAPA's website for some more. We have fact sheets and videos with all of this information about all these nematodes, and I would also recommend scanning this QR code and subscribing to the PAPA's email list to hear about management tips and then new research when we have it. Quick thank you to my advisor, Dr. Inga Zazada, and her lab at the USDA ARS in Corvallis, as well as everyone out at the OSU Hermiston Agriculture Research and Extension Center for managing my field trial in the summer. And big thanks to PAPA's for funding all of my research. Okay, thank you, and I can take any questions.
No. Back to the website page. Could you leave that up while we do questions?
Yeah, it should be the last one listed, but I could do.
Yeah, there we go.
Okay.
Perfect.
Hello, Gabby. Can you describe the distribution of nematodes in general? Are they clumped? Are they regularly distributed in the field? How would you describe them?
I think generally we find them kind of clumped. Like I think there's a lot of talk right now about like how do you best sample a pivot because we don't find them uniformly distributed across a pivot. So I would definitely say they're clumped within fields. So I would say if you are going to go take your samples, if you know you have sections that tend to have problems, I would sample in those areas. But I would still sample in the areas that you don't think will have problems because you never know.
Are you likely to see a change in their distribution across the field through time, like 3 years?
That's a good question. I'm not sure over time. My thinking though is as we like drag soil through a field, I imagine you're spreading them over time. So I would not be surprised. I just don't know if we have any actual numbers on that.
Those are very interesting questions to me because I get growers all the time who will sample their fields and get zeros.
Yeah.
And they'll treat because the last time they didn't treat, they wish they had it.
I've heard that a lot, and I think it's just because the sampling is really hard to do enough of it at a high enough quality to get a truly accurate number of what might be in a field. But I think that's why doing the best sampling you possibly can is probably the best choice.
Yeah. Thank you.
Thank you.
Gabby, we have some questions online too,
Yeah.
but before I say that, if anyone wants to take a picture of the more information page, do it now. We're going to slowly transition to the virtual speaker who's next, and sometimes that takes a little longer. Okay, so for the online question, they asked, how much should we factor in soil properties, as you mentioned, when making management decisions, or over what spatial size or scale should those decisions be made?
That is a really good question. I do not know much about fumigants and like how all of that works. So I don't feel comfortable answering in terms of like, oh, you got a nematode number and now you're trying to treat based on a fumigant based on that number. But I would just like take it into consideration in terms of sampling.
Right. I believe Inga's publishing or did just publish a paper with Catherine East on that, on soil properties as well. Yeah. Any other questions?